Have you run into this? You built your own MCP server for your own application, but it keeps choosing the wrong tool. Odds are the model isn't getting the right intent because you're not giving it enough to work with. In this video, we'll demystify how intent extraction really works and walk through the actual code powering the Notion MCP server. What if you could dump your thoughts straight into Notion without ever opening it? You can find out how it is done in this video here. In this video, I'll walk you through how I built a terminal-first brain dump tool using an MCP client, a custom MCP server, and the Notion API in the backend. You'll see the actual thought process behind the tool's design and how I implemented it, from extracting user intent to turning that into structured instructions the model understands. This is where AI meets productivity. When you're using the AI models with MCP, you're not just typing, you're trying to get something done. That desire to complete a type of task, combined with what the task description is, forms the intent. When you give a sentence to a model like GPT-4, the first thing it does is try to extract your intent, what you want, and what action is needed. If your request matches something it already understands, like convert this paragraph into a bullet list, it can follow through using built-in instructions it has seen during training. But if you're asking for something custom, like read a Notion database and summarize the latest entries, the model needs to look for a tool it can use to complete that intent. If you're like most developers, you probably dive straight into building the tool, then wonder why the model never uses it. The truth is, you're likely skipping the most important step: understanding how intent extraction works at the MCP server level. That's what we'll explore next, so your tools don't just exist, but actually get used by the model. Intent extraction is essentially an N-class classification problem. The user can say anything, but the model's job is to classify that input into one of the available tool-based intents. In our case, the model has 4 known intents, each one derived from the docstrings of available functions. These could be things like read file, write file, delete file, list files. When the user types a request like show me the contents of this file, the model maps it to the read file intent. Success. But if the user asks for something like analyze this document for top tasks and there's no matching function with that intent, the model fails to classify it. No tool, no action. Once you understand how intents work, here's a critical piece developers often miss. From where you should start designing your functions, start from the end, where the actual work is done and where the outcome, success, or failure is being informed to the model. Think what the model needs to know and what the user needs to know. Only then should you write a docstring that clearly describes what the tool does, decide on the arguments required, and work on the logic. In a brain dump Notion template, 2 actions matter most: add task and list task. Let's take the add task action and break it down. End result. This is what the model needs to complete user intent. In Notion, a task is stored as a page. After successfully creating it, Notion returns a page ID. The model expects this ID as confirmation of success. Input required. The user's task as a text string with the intent to add it to database. For example, add email the client task to database. Here the task text becomes the argument execution logic. Receive the task text from the user input. Pass it to the MCP tool designed for add task. Use Notion client to create a new page in the brain dump database. Return the Notion page ID to the model as a success signal. You might not believe how simple this is. The model reads your sentence, extracts your intent, pulls out the task, and sends it straight to Notion. All from your terminal. No clicking, no templates. Let me show you exactly how it's implemented in Python using the Notion client package. Looking at the add task tool now feels like a walk in the park, because every part of the code has already been demystified. The function name is the tool name. The docstring tells the model it's meant for the add task intent. The return statement signals success like a created page ID. Getting intent extraction right is only part of the equation. When you introduce multiple tasks, tools, and databases, your MCP server becomes a dynamic system, a database of tools, prompts, and AI resources. Your job as a developer? Think like the user. How will they ask for something? Then design tools that respond. Need inspiration? In this video, I show how I integrated Reddit data into MCP, a real-world use case that stretches beyond Notion.